All right. So it's what we call, here's another model. It's called the interactive activation model of speech production. Okay. And so here you could think of these as like a picture naming task. So you see a picture of a cat, for example, right? And here you see that let's say that there's a bunch of units, semantic units, right? Maybe this is like has fur. Actually, I think we're going to do it in a second, but let's just say that each of these three units right here are activated, right? And maybe they're just attributes, right? There may be like four legs, has fur, is a mammal, that kind of thing. Whereas these other semantic units aren't activated. And then they send activation to, and so each one of these layers is like the first one is semantics. The other layer has a bunch of units corresponding to words. And these bottom units are called phoneme layers, right? So they correspond to the phonemes or sounds that constitute a given word. And this is also called a parallel distributed processing model. Okay. And in this model, all the connections are bidirectional. So activation can flow from semantics to words, from words to semantics, from words to phonemes to words. And activation spreads through the network, and whichever word node receives the highest activation is the one that gets selected for output for saying that, right? You say whichever word unit gets the highest activation is the one that you would predict that it would say, right? And then the phonemes that receive the highest activation are selected, right? So you not only do you have to, sorry, you have to actually, the semantics get activated and then they hit the words, and then the words will also have to activate the phoneme. So you may retrieve or activate the correct word, but then incorrectly activate or select the wrong phonemes. So, so imagine if the picture, let's say a picture of a cat is shown to you, and it turns on the word node. Well, it turns on the semantics of semantics that the activation of these semantics nodes get activated, right? And then they send activation to the word nodes. So like again, I said semantics are like maybe this is furry, four legs, um, and something else, right? Well, dog, rat, and cat all share some of those features, right? So some of the activation will spread not just to the correct word, but also to related words. And then the word cat, if the word cat gets activated the most, right, then it sends activation to the phonemes. But notice, right, so the cat, and t, well, and t are similar to the phonemes in rat, right? So there's going to be some overlap in the phonological nodes that get selected, right? So the cat node could be activated, which would send the phonemes to cat, and t, and then you would just say that. But it could also potentially uh, lead to you saying the word rat instead, which I'm going to show in a second. Yeah, so of course, cat should be the most active, followed by rat, because they share semantic nodes. There's nodes that they have in common on the semantic layer, but they also have phonological nodes that they share as well. So that activation, because they share that activation, uh, rat is also going to be a little active. So here's what I actually show this, right? So here, imagine if like the three semantic units are purrs, whiskers, and furry. And then I put XYZ because it doesn't matter what those things are because we're only going to be talking about these three input or three semantic nodes, right? You got fog, dog, cat, rat, and mat. Those are your word nodes. And then you got f, r, d, k, m, a, o, t, and g as your constituent phonological nodes, right? So imagine if purrs, whiskers, and furry get activated, and they send activation to, whiskers and furry will send some activation to dog. And then cat, whiskers, and purr and furry will also get activation, send activation to cat. And then only, I think, whiskers and furry will send activation to rat. Okay, well, now you see that cat is the most active, but dog and rat are also a little active. Well, now this activation gets spread to its phonemes, right? Now you can see that R, D, K have a little bit of activation, and so does I guess and J. But notice how A and T have have double the activation. Okay, so now so now A and T are gonna be the most active phonemes, and they're gonna send their activation back up. And what will end up happening is that cat will be the most active because it's gotten its uh, activation from the semantic layer, but it's also gotten some activation from the phonological layer that was sent back up. And but rat will also get a little bit of activation because it also shares some phonemes with cat. And this will just keep happening. Yeah. Okay. So that's all I'm going to talk about that. Now I'm just going to talk a little bit about I guess I'll stop here, and in the next video I'll talk about some of the aspects of neural networks.